To understand the formation of steam at constant pressure from water, we are going to consider a cylinder fitted with a piston, and this piston can move upwards and downwards freely along the cylinder's height. And let's assume 1 kg of water kept at 0 degrees Celsius, and the volume of the water is Vf meter cube, which is going to be present under the piston. And the piston is loaded with a weight W to ensure constant pressure. So the weight ensures constant pressure. And to form steam, obviously, we are going to heat the water at 0 degrees Celsius at constant pressure. As heat is being imparted into the water, a rise in temperature will be noticed, and this rise will continue till the boiling point is reached. And at the boiling point, which is also called Ts, which is saturation temperature, the water starts boiling. And during heating up to boiling point, there will be an increase in the volume of water, and this slight change in volume is neglected. If the heat supply to the water is continued, after reaching the saturation temperature, there will be no rise in temperature. So after boiling point is reached, the temperature remains the same, and instead of increasing the temperature, the piston will be raised, which indicates increase in volume. And this is possible because of steam formation. So at saturation temperature, steam formation occurs. So the heat that is supplied that does not show any rise of temperature but changes water into vapor state is called latent heat. Latent heat is involved in changing water into its vapor state, that is steam. And we can see that the steam generated is in contact with water. As long as the steam is in contact with water, the steam is called wet steam. If the wet steam is further heated, all the water particles associated with the steam evaporate, and what we get is dry and saturated steam. So the temperature at which the dry and saturated steam is formed is saturation temperature Ts. And we can see the initial volume Vf, that is the volume of water, is now changed into the volume of the dry and saturated steam. If Vg meter cube is the volume occupied by 1 kg of dry and saturated steam, then the work done on the piston, because the steam is expanding, can be given by W is equal to P into Vg minus Vf. So this P is the constant pressure due to the weight W placed on the piston. Vg is the volume of dry and saturated steam, and Vf is the volume of water. And if we keep heating the dry and saturated steam, the temperature of the steam will increase and the volume of the steam will increase. And we are going to call this temperature as TSUP and the volume as VSUP. And the steam is called superheated steam at this stage. And the superheated steam behaves like perfect gas. This is a graphical representation of formation of steam at constant pressure from water. So we can see we have temperature against heat added to the water. The initial heating is the sensible heating of water, after which the water is evaporated at the saturation temperature and it is superheated to TSUP. And if we divide this graph, if we divide the heat added into 3, sensible heat where the water is just heated, and we have latent heat which is represented by HFG where water evaporates, and we have the heat of superheat which is represented by HSUP.